Pre-Calc B, Unit 3, Test Review Video. Let's do it. Step 1, we read it. The absolute value of 3x minus 3 is greater than 6. So the first thing we do is we take the absolute values off of it. And we know by our little trick, it's or. Take the absolute values off of it, flip the sign, make that opposite. There's a explanation we use while I teach it, but during the exam or the test review, we're just going to go with the rules. So we're going to add 3, 3x is greater than 9, divide by 3, x is greater than 3. Or add 3, 3x is less than negative 3, divide by 3, x is less than negative 1. So if we take a look at both drawings, there's my negative 1 less than, x is greater than 3, so there's my 3 greater than. So I need to explain this space, which is negative infinity all the way up to negative 1. It doesn't include negative 1, so it's parentheses, together with 3 all the way to infinity. So I look for that, and it looks like we got a match on letter A. Number 2, similar, but the absolute value of 4x minus 6 over 3 is less than 10, which is a trigger. So the first thing we do is 4x minus 6 over 3 less than 10. And number 2, 4x minus 6 over 3, flip this, greater than, take the opposite of that, and now we got two math problems to solve. So we're going to multiply this side by 3 and this side by 3. So I get 4x minus 6 less than 30. Add 6, I get 4x is less than 36. Divide by 4, I get x is less than 9. And we'll talk about that in a minute. Multiply that side by 3, multiply that side by 3. I get 4x minus 6 is greater than negative 30. Add 6 to both sides, and I get negative 24. Divide by 4, I get x is greater than negative 6. So if I draw my drawing, I'm going to start with this one, throw my negative 6 down here. Up, x is less than 9, put it here. Up and this way. The word and means whatever's in common, so it'll be all the stuff in here. So that would be negative 6 all the way up to negative 9, parentheses, because it does not, they don't share negative 6 and 9. It's not common to both of them. So we go on the hunt for that. It looks like that's letter B. Number 3 says solve it. The first thing we're going to do is get rid of the negatives by multiplying by negative 1. But don't forget, if you choose to do it that way, you got to flip the inequality whenever you multiply an inequality by a negative. So now I'm going to factor this. So I'm going to get x plus 3, x minus 2, greater than or equal to 0. So if I was to actually look at this, my zeros would be negative 3. So I'll just put it right here. Oh, negative, so just so you know, x plus 3 is greater than or equal to 0. It can include negative 3. It's a definite 0. And then x minus 2. So this is my negative 3. Here's my 2. That's another 0. And if we remember what was taught in class, this is a quadratic, which means it's a parabola. And if a is positive, it's going to be like this. So that parabola is going to come in like this. Now we're not too concerned about where this vertex is. The problem wants to know where is this greater than or equal to 0. Well, that would be true here, and that would be true here. So mathematically speaking, that would be negative infinity all the way up to negative 3, including it, together with 2 all the way up to infinity. And that would be letter A. Number 4 is similar, but it's already been factored. So if we make our little number line to get started, just like we did up here, here's a 0, which would be 2. I'll just put it right here. Oh, and it's strictly less than. But that would be 2. This would be negative 2. Just put it down here. Finding my zeros to get started. And then negative 4. Now remember, if we go x times x squared times x, that'll be x to the 4th. And because there's no negatives out here, or here, or here, or here, we know that a is going to be greater than 0. So if we have a quartic with a greater than 0, it's going to be winner, winner, chicken dinner. But this says that it's going to be a bounce off this 0. So this negative 2, there's going to be a bounce. So I'm going to start with the outer extremities. I know it's going to go like this, and I know it's going to be like this. So this has to go underneath because it has to go through this one. Comes up and bounces. And again, we're not worried about the accuracy of our drawing because all we're looking for is where does this graph go beneath the x-axis. And so we know that to be true between here and here, not including the actual zeros, and here, not including the actual zeros. So to explain this space, that would be negative 4 to negative 2, together with this space, negative 2 all the way to 2. And that would be letter D. Okay, number 5. Which point is included in the solution set of this inequality? And that hint might be a little too helpful, I think. But we'll just plug this in. Here's my x, here's my y. So that would say 10 is less than or equal to 1 cubed is 1 times 2 is 2. 1 squared is 1 times 5 is 5. And then minus 3. So the question is 10 less than or equal to 4? No. Let's try this one. Y is less than or equal to negative 2 cubed is negative 8 times 2 is negative 16. Negative 2 squared is 4 times 5 is 20. Negative 2 times negative 3 is 6. So we whittle that down. This is 26 minus 16 is 10. Is that true? No. All right, so I'm just going to jump to, okay, letter C is going to work. I just cheated and looked at the answers. Here's our x, here's our y. So y is less than or equal to 2 cubed is 8 times 2 is 16. 2 squared is 4 times 5 is 20. 2 times negative 3 is negative 6. So negative 5 is less than or equal to, that's 36 minus 6 is 30, and that's a yes. So there's my answer. Number 6 is actually what we did earlier on numbers 2 and 1. So the instructions just seem a little more hectic, but don't worry about it. It's what you do anyways. So if we read this, it's the absolute value of 3x minus 2 is greater than 10. That's a key. So step 1, take the absolute values off. Step 2, take the absolute values off, flip the sign, flip the value. But remember, the word is or. So you take the sum of this and add it to the sum of this. So we add 2, we get 3x is greater than 12. Divide by 3, we get x is greater than 4. Add 2, we get 3x is less than negative 8. Divide by 3, we get x is less than 8 thirds. So if we actually use this number line right here, I'm going to put my 4 right here. This is just that. X is less than negative 8 thirds. I'm just going to throw it right here, and that would be that. So my two answers are this space and this space, because the word or means the sum of these two events. So I would say it, negative infinity all the way to negative 8 thirds, together with 4 all the way to infinity. So number 7 is implying that you might need to graph it well. I don't think we're going to have to do that, because if we just look at this, we know that this is a cubic and a is positive, which means it's going to look like this, generally speaking. So we're going to first factor this by taking an x out. So we'd have x squared minus 6x plus 9. Then that would continue into x minus 3 squared times x is less than 0. So my two zeros would be 3. I'm going to put it right here. And my other 0 would be 0. I'm going to put it right here. A couple things. If it looks like this, but here are my zeros, I'm going to go with the outer extremities first. It goes down from that point on, and then it goes up and to the right from that point on. But it's going to bounce off this 0 because of that 2. So it's going to come like this, go up, and come down. Has to. And now the problem says, where are the values negative? That means beneath the x-axis. So I would say that's the only place right there. Well, where is that? That would be negative infinity all the way up to 0. But the question is, do I put a bracket or a parentheses? That would be a parentheses because it's strictly less than 0, not equals 0. So it's beneath it. Okay, number 8 is actually an inequality, and we worked on graphing these inequalities. These are a little different than these. We're going to have to be a little bit more specific with this. And so this one's asking you, okay, you better realize that this is a y equals x squared kind, which is a parabola that goes like this. The problem is we need to know where the vertex is. And the only way we can figure out what the vertex is by remembering this fancy generic way of doing parabolas where this only comes from a perfect square trinomial. So if we look at this and ask ourselves, is this a perfect square trinomial? The answer is no. Now, if a student actually noticed that this was x minus 5, x plus 1, this is good. This would be the 1, 2, 3, 4, 5, 0. This would be negative 1. But the problem with doing it this way is this does not tell you where the vertex is. So it could be anywhere. And we don't know. So that's why this technique is discouraged. We need a perfect square trinomial, which brings us back to our basic completing the square skills. So x squared minus 4x plus blank minus 5 plus blank. Take half of this, which is negative 2, square it, and that's a 4. Notice this is a perfect square trinomial. But if I put a plus 4 there, I got to balance it out by putting a minus 4 there. And now I'm going to work on this and factor it. So it'd be y is less than or equal to x minus 2 squared minus 9, which tells me the vertex moves right 2 and then down 9. So let's see, 1, 2, and then down 9 would be right there. Because my a is positive, it's going to be up like this. And remember, we already figured out that our zeros were going to be 5 and negative 1. So 1, 2, 3, 4, 5, and negative 1. So we're going to draw it in there like this. And I got lucky because these would be dotted if it was strictly less than. But because it's less than or equal to, it's going to be solid. Now in class we talked about reading from the y to this, and that would be y is less than, which is giving you the idea that your answer, your solution set is going to be beneath the graph. And I said if you're curious, then plug 0, 0 in to see if that works. Well, 0 is less than or equal to 0 minus 5. Is this true? No. That's why this is not in the shaded area. It's just everything outside the parabola. Numbers 9 and 10 are going to have to be done on part 2. So we'll see you in 2 seconds in part 2. Not enough time.